Have you ever stopped to wonder what truly happens in the final moments of life? It is a question that has captivated humanity for thousands of years. We have looked to philosophy, religion, art. But what does science have to say? What is going on inside the most complex organ we know of, the human brain, as we take our last breath? For so long, this has been a complete mystery, a black box we could not open. When the heart stops, the brain simply and immediately shuts down like a computer being unplugged from the wall. But what if that assumption is wrong? What if the brain has one last powerful story to tell? This profound question is not just a matter of idle curiosity, it touches the very core of what it means to be human. It involves our consciousness, our memories, our sense of self. The transition from life to death is the single most universal experience we will all face, yet it remains the least understood. That is, until a remarkable and completely unplanned event gave us our very first glimpse into this mysterious world, changing everything we thought we knew about the end of life. The story of this incredible discovery begins not with a planned experiment but with a tragic medical situation. It was a complete accident of science. Neurosurgeon Dr. Ajmal Zemar and his team were treating an 87-year-old patient in a hospital in Estonia. The patient had developed epilepsy after a fall, and the doctors were using a continuous electroencephalogram, or EEG, to monitor his brain for seizures. This machine was constantly recording the electrical signals coming from his brain, giving the medical team a live feed of his neural activity. The goal was simply to help the patient and manage his condition. No one could have predicted what was about to happen next. Suddenly, and tragically, the patient suffered a massive heart attack and passed away. It was a sad and unexpected turn of events. However, because the EEG machine was still connected and running, the doctors inadvertently captured something that no scientist had ever recorded before: the brain activity of a human being at the exact moment of death. For about 15 minutes the machine kept recording, capturing the window of time just before and just after the patient's heart stopped beating. To truly appreciate what Dr. Zemar's team discovered, it helps to understand the tool they were using: the electroencephalogram, or EEG. Think of your brain as a massive orchestra with billions of tiny musicians called neurons. Each neuron communicates with others using tiny electrical pulses. When you think, feel, remember, dream, these neurons fire in complex patterns, creating a symphony of electrical activity. An EEG is like placing a set of highly sensitive microphones around this orchestra. It doesn't hear each individual musician, but it picks up the collective rhythm of the whole brain. The EEG machine uses small metal discs called electrodes placed on the scalp. These electrodes detect faint electrical rhythms, brain waves, produced by all that neural activity. Doctors have used EEGs for decades to diagnose epilepsy, sleep disorders, brain injuries. Awake, asleep, relaxed, concentrating. What makes this particular EEG recording so important is its timing. It was the first time we could listen to the brain's symphony during its final performance. So, what exactly did the scientists see when they analyzed the EEG recording from the dying patient? What they observed was nothing short of extraordinary. As the patient's heart stopped beating and he was declared clinically dead, his brain did not simply shut down. Instead, in the 30 seconds before and after the heart stopped, the EEG detected a powerful and organized surge in a specific type of brain wave. These were not just random electrical flickers, they were coherent patterns of activity. The brain appeared to be doing something very specific and very deliberate. The brain waves that surged were gamma waves. This is incredibly significant. In a living, healthy brain, gamma waves are associated with some of the highest forms of cognitive function. Memory, recall, deep concentration, meditation, dreaming. When you're trying to remember a specific detail from your past, or when you are deeply engrossed in a task, your brain is likely producing a lot of gamma waves. They are the signature of a brain that is actively processing information and integrating different pieces of it into a coherent whole. They are, in many ways, the hallmark of conscious experience. To find such a strong, organized burst of gamma waves around the time of death was stunning. It suggested that the patient's brain might have been engaged in a final, vivid burst of mental activity. The patterns were similar to those seen when a person is actively retrieving memories or dreaming. Dr. Zemar and his colleagues hypothesized that this could be the brain playing back a last recall of life. It is possible that the brain was replaying significant life events, a highlight reel of memories, in the final moments before it ceased to function entirely. This was the first physiological evidence that might support the idea of your life flashing before your eyes. This groundbreaking discovery immediately raises a tantalizing and profound possibility. Could consciousness persist even for a short time after the body is clinically dead? The organized gamma waves observed in the dying brain are the same type of waves associated with conscious perception and memory. This finding provides a potential scientific explanation for near-death experiences, NDEs. For generations, resuscitated people have returned with incredible stories. Feeling of peace, seeing a bright light floating outside their own bodies, a rapid and vivid review of their entire lives. These accounts are consistent across cultures. Science long dismissed them as hallucinations from lack of oxygen or a disorganized brain. Dr. Zemmer's organized gamma burst challenges that view. Near-death experiences may be a structured neurological event. It links a spiritual feeling to a measurable brain process. Let's take a moment step away from the science. Imagine what this final burst might actually feel like. Close your eyes and picture it. The world outside is fading away. The sounds of the hospital room, the feeling of the bed sheets, the awareness of your own body, it all begins to recede. But inside your mind something incredible is happening. It is not darkness or silence. Instead, a vibrant, rapid cascade of memories begins to unfold. Not like watching a movie on a screen. Much more immersive, much more real. Warmth of the sun on your face, childhood vacation. Laughter of a loved one from decades ago. Taste of the cake from your wedding day. The thrill of a personal achievement. These are not faint recollections, they are vivid, fully formed experiences rushing through your consciousness. Your entire life, not chronological but a tapestry of meaningful moments woven into a final coherent perception. The brain, in its final act, is not just randomly firing, it is organizing your memories, the essence of who you are, into one last symphony. The discovery of this organized brain activity at the end of life is more than just a fascinating scientific curiosity. It has profound implications for both science and humanity. For science, it opens up an entirely new field of research into what we could call the neuroscience of death. This single case study acts as a proof of concept, demonstrating that the dying brain is not a silent organ. This research also has important practical implications for medicine. For example, it raises crucial questions about determining the exact moment of death and the timing of medical procedures like organ donation. If the brain, and potentially consciousness, remains active for a short period after the heart stops, it forces us to reconsider our ethical and medical definitions. It could influence how we care for patients at the end of their lives, encouraging a greater sense of reverence and respect for the process, knowing that a profound internal experience might be unfolding. On a deeper, more human level, this discovery touches all of us. Death is a universal certainty, and for many, it is a source of fear and anxiety about the unknown. This research offers a small but powerful glimmer of comfort, the idea that our life might not just end abruptly but culminate in a final, vivid review of our most cherished memories, is a beautiful and reassuring concept. It tells us that the final chapter of our life story, written in the electrical language of our brain, might be the most incredible one of all. In light of these discoveries, some scientists have drawn connections to the ORCH, or theory, or orchestrated objective reduction. This theory, proposed by Sir Roger Penrose and Stuart Hameroff, suggests that consciousness arises from quantum processes within the brain's microtubules. If the brain's final organized activity is indeed a quantum event, it raises the possibility that this information could expand and exit the body as organized quantum information, merging into the larger quantum field. In this view, the last symphony of the brain might not simply fade away, but could become part of a universal quantum tapestry, carrying the essence of our conscious experience beyond physical life. But what does this mean for our understanding of life and death? If consciousness, or at least the patterns of our thoughts and memories, truly merge into the quantum field, it suggests a form of immortality, not as the survival of our individual personalities, but as the persistence of our experiences as information woven into the very fabric of the universe. In this perspective, our final moments are not lost, but become part of a greater whole, a universal memory bank, where the echoes of every life contribute to the ongoing story of existence itself. While science is only beginning to explore these mysteries, the idea that our consciousness could leave a lasting imprint on the cosmos is both humbling and awe-inspiring. It invites us to see ourselves not as isolated beings but as threads in a vast interconnected tapestry, where the end of one story is woven seamlessly into the beginning of another.